Hi there, welcome to my channel Mandu to Fundu. In this video, I am going to discuss about the solution for the nested list weight sum problem. Let's look at the problem description. We are given a nested list of integers and each element in the list is either an integer or it is another list. So in the example 1, the list has 3 elements. And the first element is itself a list which has 2 elements, and the second one is an integer, third one is another list. The depth of any integer is the number of lists it is part of. So in this case, number 1, it is part of 2 lists, so the depth is 2. We have to multiply each integer by its depth or weight and then add all of them and return. 1 times 2, 1 times 2, 2 times 1, 1 times 2, 1 times 2, total 10. We can view this input data as a tree. So in that, root node and intermediate node represents a list, and all the leaf nodes represent an integers. In order to find the solution for the whole problem, first we have to find the solution for this sub-problem of the same form. We can solve this kind of problem using recursion. The solution is computed from bottom up. Let's look at the flowchart for this solution. Nested list and the weight 1 are passed as an input, and then we initialize the weighted sum to 0. We loop through all the elements in the nested list. If the nested list of I is an integer, then we multiply that number with the weight and add it to the weighted sum. If it is a list, we increment the weight and make a recursive call to process the list in that entry, and the return value will be added to the weighted sum, and then we loop through again. Once all the elements are processed, we come out of the loop and return the weighted sum. Let's move on to the coding part. First, I am initializing the weight to 0, and then I am calling the helper function and pass the nested input list and then the incremented weight. Now I'm going to write the helper function which will process all the elements in the past input list. Initializing the weighted sum to 0. Assigning the length of the input list to the count. If the current element is an integer, then we multiply that integer with the current weight and add it to the weighted sum. Else, we make a recursive call, and in that call we pass the sublist and the incremented weight, and the return value will be added to the weighted sum. At the end, the weighted sum will be returned back to the caller. Let me run this program. Okay, accepted. I'm going to submit this program. Cool. The program is accepted. Let's do the code walkthrough with sample input. Let's take this in a nested list for code walkthrough. This basically has two sublists and one integer. So in the depth sum function, we initialize the weight to 0, and then we make a call to depth sum helper function with incremented weight and the given input list. So now we have weight 1, and we will be processing these three elements with that weight. So the first element is a list, so we will be making a recursive call to the helper function with weight 2. Since this sublist has only integers, we compute the weighted sum 4 and return it back to the caller. The second element is an integer, so we multiply that value with the weight and add it to the weighted sum. The third element is also a list, so we will be making a recursive call to the helper function and compute the weighted sum value 4 and return that back to the caller. After processing the three elements, finally we get the weighted sum 10, and we will be returning back to depth sum function, which will be in turn returning back to the main function. Next, we will see the time and space complexity of this solution. I'm using this input list for my analysis. This has three elements. Two of them are a sublist, which in turn have two integers. This for loop performed three iterations when the helper function was called with three elements. When the nested call is made for processing this sublist, for loop perform two iterations, and again for another two iterations for that list. So the totally 7 times that for loop, 7 iterations it do. The input list has totally 5 elements and then 2 sublists. So if we add them, that is also 7. So the time complexity is order of n plus m, where n is the total number of elements in the input and m is the total number of sublist in the input. So let's look at the space complexity. So here we do not allocate any additional space, but whenever we make a recursive call, we use the stack space. To process this input, we have to make maximum 2 nested calls to the helper function. So the space complexity of this solution is order of m, where m is the maximum depth of an integer in that input. Thanks for watching this video. Have a great day.